Those of us doing science experiments with temperature ask ourselves, why would I want to go and use a digital temperature probe when I have thermometers at work? Well, I have 3 reasons for you, and then a bonus 4th reason. Number 1, sometimes the experiments you want to do give us things that are too hot, such as taking the temperature of the water coming out of your Keurig, and then using that to compare the temperature of the paper cup versus the coffee mug. And you wanted to do some temperature and insulation experiments with the mittens that your students have. Also, what if the experiment takes too long? Such as this cup of water here where I filled it with ice cubes and then let it sit for 2 hours under a heat lamp. Notice the strange things that happen. Why does the temperature go up in this moment and then stay flat for a little while? What's happening? What happens if you add a bunch of salt to that? Also, you could do experiments where things happen too quickly. In this example, I take a temperature probe, I wrap it in some tissue paper, I get it wet, and then I stick it in front of a fan, and then in less than 30 seconds, we watch the temperature drop compared to the temperature probe that was left in the cup. And your bonus 4th reason is you can take this temperature probe and the LabQuest device that logs the temperature data for you and just stick the whole thing outside and leave it overnight. Just drop it into an igloo cooler. So in conclusion, the temperature probe reveals trends, and it allows you to see patterns that would not otherwise be visible to us unless we were taking data continuously. Here's one final challenge for your students. You could pose the question, what is the shape of the line graph that hot water makes as it cools down to room temperature? Is it a straight line, or is it one of these curve shapes? And then have them develop a model. This fits in nicely with the next generation science standards.